Today I'm going to talk to y'all about serverless with Ruby, and we will be talking about AWS. We'll be talking a little bit about JavaScript and my abiding hatred for it, as well as a little bit of JRuby and my never-dying love for it. As we kind of go into this, serverless is an interesting new platform. All the major cloud providers are providing some kind of serverless approach to being able to deploy code. And to address this, I want to talk with y'all through three questions. The first is, what is serverless? Getting us a definition of it that we can kind of talk about together. How do we use Ruby on these various serverless platforms, particularly AWS, and we'll talk about why AWS in particular in a moment. And then when should we use serverless? But before we get to that, give you a little bit of an introduction to who I am. Hello, I am James Thompson. I am a principal software engineer for MavenLink. We have almost a whole row here. Come find us if you're interested in talking about what we do as a company. You can find me online at Plain Programmer on GitHub, on Facebook, on Twitter. I think I'm the only Plain Programmer on the internet, but who knows? Maybe there's somebody else who's stolen my handle on MySpace or some such. Now, by way of background, I have been doing software development professionally since 2003, but I've been a hobbyist since the mid-90s. How many of y'all learned to program on something other than an IBM-compatible PC? All right. I learned on an Apple IIe in 5th grade because I went to a very peculiar private school that thought it was a great idea to turn a bunch of 5th graders loose on very expensive hardware. Now, I started using Ruby in 2006 as a way to escape Perl and PHP, and I have enjoyed my career much more since that time. I also have a somewhat peculiar background. We talked about CC yesterday, having a musical background, the number of folks here who come from different backgrounds. My educational background is actually in religious studies and church history. I have no formal training in computer science or programming. It's something that I've completely taught myself since I was young, and I think this is one of the kind of best communities, technically speaking, the Ruby community, because we have been historically very accepting and inviting to folks coming from different backgrounds. And I think that's something that we need to keep doing going into the future as we think about folks coming out of dev boot camps who are going to be coming from diverse backgrounds that are going to look unusual, but they present a lot of value to us as a community and as an industry. So if you want to know any more about me, come track me down later. And if you really feel like clapping, go for it. I heard a couple people kind of very hesitant, not sure if it's the right thing to do. Clapping for me is probably never the correct thing to do. It's just going to make me a worse person. So what is serverless? Let's get to this first question. In short, it is a buzzword. It's market speak. It is a way to describe and sell you something. Everybody in the cloud space right now, everybody who's big is trying to sell serverless as a technology and as a choice. And so it's yet another entry into our never-ending glossary of tech terms. But what is it? What is the meaning of it? And really, it's going to depend a lot on who you ask. Sometimes serverless refers to this idea of building rich client applications that have no real persistent back-end systems. They rely on back-end as a service providers, so authentication as a service, or any number of whatever as a service back-ends that then feed a front-end rich client experience for users. And this isn't the definition that I'm going to be working from today. Instead, I'm going to be working from the one that typifies what we see with services like Azure Functions, Google Cloud Functions, and AWS Lambda. And that one refers to server-side logic that is deployed on a platform that provides stateless, event-triggered, and ephemeral compute power. And so as we think about this, this definition is the one that I'll be using. It's the one represented by all the major cloud providers as they are doing their various serverless offerings. And I think it is by far the most interesting to us from an architectural standpoint because it provides some real solutions to problems many of us, if we're building web applications, already have already solved in ways that can at times be a bit painful. Serverless provides some options to be able to solve those problems in a new, interesting way that I think potentially could be less painful. And we'll come back to this definition in particular when we get to the end of the presentation, talking about when should we use serverless. So how do we use serverless with Ruby? Unfortunately, Ruby is not a first-class citizen on any of the major cloud platforms, at least not for their serverless offerings. If you look at Google Cloud Functions, they only support JavaScript. That sucks. If all you can do is run JavaScript on a particular platform, that platform is anemic in a very serious way. If you look at Azure Functions, you can run JavaScript, you can run C#, you can run F#, you can run PHP and Python, and they will eventually support other languages. On AWS Lambda, you can support JavaScript and Java and a host of other languages. And unfortunately, there's no real option for us who develop Ruby and who love Ruby to deploy on these as first-class citizens. Now, there are tools like Fission for Kubernetes that will allow you, if you're rolling your own kind of cloud infrastructure, you can use a tool like Fission to provide kind of this serverless runtime environment, and you can run whatever you can manage to package in an environment like that. But regarding Ruby, there are really two usable approaches that we can use, and unfortunately, because of the nature of the platforms and the nature of these approaches, they kind of lock us into AWS Lambda. Eventually, hopefully, the various cloud providers will become more agnostic about how you deploy code into these serverless containers. But for right now, there's two approaches that work on AWS Lambda, one using MRI and one using JRuby. Now, before I move on, who knows what I'm talking, or how many people don't know what I'm talking about when I refer to MRI? Okay, got a couple of folks here. MRI refers to Matz's Ruby interpreter. So it is the C Ruby. It's the official Ruby. It's the only Ruby that is considered to be 100% pure, compatible Ruby, because it is the definition of Ruby. So whenever I refer to MRI, that's what I'm referring to, the Ruby runtime written by Matz. Whenever I refer to JRuby, I'm referring to the project that allows Ruby to run on top of the JVM. And that's a great project. If you haven't checked it out, you should totally do that. JRuby has a lot of endearing qualities, not the least of which is the fact that it runs on the JVM. Now, as we look at these two different approaches, there's a number of pitfalls that come with each of them. And MRI by far has the most pitfalls when we want to talk about how to deploy it on AWS Lambda. JRuby also has pitfalls, but they're much more typical for using an alternative Ruby implementation. So if you want to work with MRI, and I think it's worth going and actually at least looking at this as an example, even though I think this is a very poor option for Rubyists wanting to deploy to a serverless platform, you can go and check out this particular GitHub repo, which I'll have a couple of code samples from that look at how you can package MRI using Traveling Ruby, which is a project maintained by the Fusion team, the guys behind Fusion Passenger, to package up your Ruby runtime so that it can be distributed to other systems. And with that, there is a very nasty caveat that goes along with that. There is this, and this is the first major pitfall, is that to use MRI in a serverless environment, you're going to have to write JavaScript like this. And this is not pleasant at all, because by the time you've written this code, you might as well just said, hell with it, I'm just going to write the whole damn thing in JavaScript. And there's a number of problems with this approach. But let's focus on the lines of code that are actually meaningful to us, because there's a lot of noise in this. These are the 3 lines of code that actually matter, where we are going through and we're exporting a handler that can be invoked by the AWS Lambda platform. we're recognizing a command that we're going to run, which that's the reference to the Ruby script that is going to get run via MRI. And then we have this call to exec, where we are actually spawning a child process to run our Ruby in, which will then return back to the JavaScript code in order to return back to the user. So you have to have this JavaScript wrapper calling out to a child process in order to get MRI functioning on AWS Lambda. And this has a number of problems where if we look at this code, we notice that event and context, the two arguments that are going into the function here, into the handler, they're never passed on to the Ruby code. And if you want to pass them on, you're going to have to figure out how to encode them either into an environment variable or into a command line argument to your script in order to get them to work. And normally the event is coming in as a JSON payload. So that one, you can probably get it into a string format that you can shove along in some usable way. The context object, though, is a very rich object provided by the AWS Lambda platform. And if you care about any of that, you're going to need to actually break that down and send those details along as you need them to your Ruby code. And so this is not a very friendly way to be able to write Ruby and have it deployed on AWS Lambda, but it's totally possible. If you really need the MRI runtime, this is viable, it's just not pleasant. Another big pitfall is the use of traveling Ruby. This is actually a big restriction because you're essentially on your own to produce the appropriate version of the MRI runtime that you need for your code. You're going to be stuck building this because the last public build for this was Ruby 2.2.2. It's not been updated recently, and there are some known gotchas with regards to certain C extensions working with traveling Ruby because it's meant to be more portable even than MRI's standard install. So you're not going to get full support for all the Ruby gems that are out there. So that's a significant drawback. But really, it's just too damn clever. This approach requires you to maintain JavaScript and Ruby side by side, and at that point, in this kind of an approach, you might as well just be writing JavaScript, which, if that's your thing, by all means, go for it. I don't have any interest in doing that nonsense. Yeah. So, what about serverless JRuby? This, I think, is actually the much more compelling option for us as Rubyists, because we can actually run Ruby as close to being a first-class citizen on this platform as is possible right now. Because we're able to leverage the presence of the Java runtime, we can actually get our code running in a reasonable amount of time, reasonable tooling, and not have to do any weird JavaScript bullshit. So we can just completely avoid it. And to prove that, this is all the code that you need to write to be able to deploy on AWS Lambda. There's no Java, there's no JavaScript, thank God. And the only other code that is necessary is going to be a build file, which can be provided in Rake. If we go back to this slide and look at that GitHub repo, there's only 3 files that are absolutely necessary to get that code that I just showed running on AWS Lambda. There's the JRuby complete jar file, which has the entire JRuby runtime that can be packaged up for distribution. There's a Rake file that calls out to Ant, which is a Java build tool similar to Rake, but the Rake file calls to Ant in order to get the Java tooling kind of set up more easily. And that generates a jar file from our Ruby code. It takes our Ruby code and packages it up as a Java executable file. And once that's done, you can deploy that onto AWS Lambda just like any other Java project. And so this is actually probably the most appealing way to get Ruby onto AWS Lambda because you can actually just write Ruby code. And you can test it exactly the way you would any other Ruby code. You're able to work with it as Ruby because it is Ruby. Now, it's going to ultimately run on the JRuby runtime, and there are some restrictions there, but they're understood by the community as a whole. You have support within the JRuby community and the Ruby community at large for a much larger set of Ruby gems and other supporting tooling. Now, with this, we can see that we've got this name argument that's coming into this particular method. That's the event. In this case, for this particular code, the event payload is just a simple string. But normally, it would be a JSON payload. And you can write plain old Ruby objects that can take that JSON payload and explode it how you want to interact with it, and then work with that within your AWS Lambda functions. You can do the same thing with context, although it's a little bit more complicated because you'll have to bring in the actual AWS SDK stuff for the Lambda context object. But it's possible because JRuby can map any Java object to Ruby and back again in most cases. And so you can get all of the capabilities that you have available in writing Java functions for AWS Lambda from Ruby. Now, one thing I've not done yet with any of my sample code is actually deploy any Ruby gems to AWS Lambda, but because they are either just plain Ruby code, or if they have native extensions or have something like native extensions for Java, they will have all the necessary code as part of the gem, and it's just a matter of getting it into the right place for the package manager to be able to bundle it all up and ship the jar file. And so that's the next iteration that I'll be making on this particular example code, is to actually demonstrate how to get something like Active Record with a JDBC adapter so that you can talk to services like DynamoDB or a MySQL RDS instance or even a Postgres RDS instance. It's all possible because the tooling's already there, and it's either plain Ruby code, which JRuby can run just fine, or it's going to be jar files that you just need to package up with your code to ship it out. And so the only gap here is the tooling. There's no existing tooling that I'm aware of to make this process easier, and so, like any good hacker, I'm going to do my best to actually build some of that tooling because I really like this. Now, despite how easy this is as an approach compared to, say, MRI, there are some really notable pitfalls. The first is Ruby gems. If you're using a Ruby gem that only provides a C extension to MRI, you're going to be out of luck using that with JRuby. And you're especially going to be out of luck using it JRuby on AWS Lambda because you can't guarantee that the C extension stuff that JRuby provides will work at all in that context. And so while there are some options to get some C extensions working with JRuby, you shouldn't do that. You should instead try to avoid those gems, find ways to work around it if at all possible. And so this is a very similar pitfall to traveling Ruby if you're trying to use MRI, because it can't use all of the gems either for the exact same reason. The C extensions just cannot be reliably supported in the runtime environment of AWS Lambda. Next, you do have to distribute the JRuby complete jar file. And that is 22 megabytes of code that you're not going to be using all of. That includes the entire Ruby standard library, the entire core library, and a bunch of other supporting code as well. I've been trying to figure out how to get down to being able to use just JRuby's core jar file, but there's a few additional libraries that even it requires just to get that simple example I showed earlier running. It requires the JEncodings jar file, which handles some things with string encoding, and a few other things that, to me, seem like they should be part of the core jar, because if you have a programming language and you can't work with strings, there seems to be kind of a fundamentally missing piece there. So I'm not sure why that's not included as part of the JRuby core file. Also, because of this additional overhead of shipping the jar file, the minimum amount of RAM that I was able to configure one of these functions to run with, even for that very simple example, was 384 megabytes of memory. Now, oddly enough, the AWS console consistently reported that the maximum memory utilization was well below the 128 megabytes that their smallest option allows for. But for whatever reason, the code just would not boot up properly. And so I'd really like to see if there's a way to slim this down so that for some functions we can actually deploy this into the smallest available container. Let's see. Now, like I've already said, this code can be tested just like any other code. You write it just like any other Ruby code because it is, at the end of the day, just Ruby code. And this makes this the most appealing way to get Ruby running, particularly on the AWS Lambda platform. And unfortunately, because of the state of things right now, that's the only place you're going to be able to get Ruby code running on a serverless platform. So the only remaining question is, when should we use serverless? When is this a good option? This is where we'll want to return back to our definition, which was when server-side logic is deployed to a platform that provides stateless, event-triggered, and ephemeral compute power, that platform can be called serverless. And so there are three important functional distinctives that are part of that definition. The first one is that the serverless environment needs to be stateless, or is stateless. And this means that there is no persistent runtime or other way for you to carry over information from one request to another. There are no persistent database connections kept around because your code is not kept running on anything. This means that any meaningful state that your functions need, they're going to have to get for themselves. This means that you're going to have this obvious queue to avoid any unnecessary state, to avoid anything that your functions don't absolutely need in order to execute their job. And this should encourage us to build the smallest meaningful units of work possible. Second, your code is event triggered. All the serverless platforms provide numerous event sources, most of them originating on those particular platforms. So Google has events that will trigger their functions whenever you upload to their cloud storage mediums. Same thing with Azure functions, and the same thing with AWS. So you have a lot of these diverse event sources, as well as the use of API gateways to allow for interactions using standard HTTP requests. Finally, the compute resources are ephemeral. This is related to the stateless nature of how these environments are run, but goes a little bit further because when you deploy code to the platform, it's not going to immediately put that onto a server and keep that running for you. There's not going to be any idle server processes running in order to keep your code up and going. It's not going to be keeping a hot standby there for you. Instead, your code is going to be loaded just in time and is going to be scaled and reaped automatically as necessary based on actual demand. This is where the economics of serverless become really compelling because the smallest unit of compute in terms of time is 100 milliseconds. And the smallest unit of memory is 128 megabytes, scalable up to 15 gigabytes if you have a method that really requires that kind of memory footprint. And so with that, you have a much more granular way of having these resources made available to you in an on-demand, just-in-time sort of way. And when your system is idling, when you don't have any requests coming in, you're not paying for any compute utilization because there is none. So let's consider this really simple architectural diagram. This is what a serverless system might look like in a very simplified sort of way. We have an API gateway, which is another service that most of the cloud providers are offering to put in front of their serverless options. And with this, this is able to translate HTTP requests into events that can then trigger serverless functions. We have the client, we have the database, we have S3, which are all services that if we've built moderately sized applications, we'll be familiar with these kinds of things: file storage, databases, and then whatever kind of client we have, whether it's mobile or web, whatever it might be. But then we have these functions on the backside of the API gateway, and these are the things that are triggered by various kinds of events. We have this notion of resizing an image, or finding a product, or adding a review. And these are all very granular units of work. And the more granular the unit of work, the better a use case serverless is going to provide for representing that work architecturally. Now, each of these will be independently tested, written, and deployed. So this makes them very similar to microservices, except way more granular than most people do their microservices. Some people go a little overboard with microservices and take the micro part of the name a little too seriously. This is, if that's your bent, serverless is probably the platform you ought to be looking at because it's going to get down to that single function of granularity. And so each of these will scale completely independently based on the requirements of their particular load profiles. And of course, these are all going to be event triggered. So they're not going to spin up until they're needed. With the resize image as an example, if we have an image, say, that gets uploaded to S3, that S3 upload event can trigger this service to spin up, do whatever it needs to in terms of processing the image, and to ship that image either back to S3 or off to a CDN, whatever the case may be. That request could also originate with the API Gateway or be triggered directly. It all depends on how we want to configure and consume these particular services. And this is probably the most obvious place where we can actually replace things that we're doing today with serverless. How many of you have apps that have to resize images? Right? How many of you have apps where you need to do CSV exports? Right? How many of you have anything that actually requires that it gets shipped off to a delayed job or rescue or sidekick? Okay? Those things are all candidates for serverless. If you can represent your unit of work as a single method invocation with defined inputs and outputs, you can represent it in a serverless context. And things like image resizing or CSV exports, those are things that can be easily represented within a serverless context. But there are risks. I don't think that we should go out and build our next app on serverless alone. I don't think the platform and the market is well defined enough. The best practices for using serverless are not yet fully understood. And I just generally am somewhat risk averse. I tend to live by the mantra of choose boring but well understood technologies, which is why I continue to like Ruby and the JVM, because they are both boring and well understood at this point. But serverless is really compelling for any workload that can rely on the available event sources that the various cloud providers offer, and where the units of work are computationally intensive. If you have an I/O intensive workload, serverless may or may not be the best choice for you. But if you have a computationally intensive workload, serverless has very interesting options and provides interesting ways to replace things that many of our Ruby apps are already doing. And the advantage that this would have over something like delayed job or rescue or sidekick is, because these are event triggered, you don't have to maintain a queue. AWS is going to provide that for you. They're going to keep track of the events as they come in. You just need to figure out what events need to trigger what services and how to actually do the work that's necessary. Serverless also makes sense for anything that has an unknown or highly variable load profile. So anything where you're not sure what the demand is going to be, or you know the demand is going to spike and ebb and is going to be all over the place in a regular kind of, or a very irregular way, serverless is something worth considering. So anything that you have in your applications that is either focused on a particular unit of computational work, or where you have these kind of these variable load cycles, is something that you should consider. But the trick is identifying the right workloads. And that's the part that's going to require everybody who wants to use serverless to actually think about our applications in ways that we're probably not accustomed to. Because we're not going to be thinking about this just from the standpoint of tooling, because there's not a lot of tooling out there right now for this. We're going to have to think about what is the problem that we're trying to solve? What is the unit of work that we're trying to get done? And until we can answer that effectively, choosing the technology, whether it's Sidekick, Rescue, Redis, or delayed job, or serverless, is not really a meaningful conversation. So with that, thank you for your time and listening to me. Thanks to the organizers for inviting me to come and speak, and I will do my best to answer any questions y'all might have.
I've been using serverless a little bit, but the ramp-up time and the memory usage for what I do is very small, but I do a node. Mm-hmm. Do you see a higher cost for running JRuby on that?
I haven't actually done any straight-up comparisons between, say, a JavaScript implementation of something and the JRuby implementation. What I've seen with that very simple hello world example was that memory utilization, ramp-up time didn't seem to be an issue at all. Once the code was loaded on the platform, it seemed to, the response times were sub 100 milliseconds. So they're well below the smallest billable unit. In many cases, they were down in the 10 to 20 millisecond range. As far as memory utilization, they were consistently below the 128 meg limit for the smallest unit on AWS Lambda, but for whatever reason, unless I allocated 384 megs, they wouldn't boot properly. And so I'm not sure what the differentiator is, what's going wrong on the AWS console where it's telling me it's only consuming 100 megs of RAM, but unless I give it 384, the process won't start correctly. No idea what's going on there. Haven't really had the time to investigate that or ask anybody who would be able to give me a definitive answer. But I don't think there's going to be any significant performance barriers to using JRuby.
I'm more interested in the cost difference.
Yeah, and I think that's going to come down to if you have to allocate the 384 megs of RAM, and what was it, if Node allows you to allocate just the 128, that is going to have a cost differential. And so.
What tooling have you created now, and this fall, what are the first areas of tooling you see?
Yeah, so the only tooling that exists right now in the repo that I shared earlier is a rake file. And all that rake file does is it knows where to find the JRuby jar file because it's part of the repo. It knows where to look for my Ruby code, and then it has the necessary ant commands to actually package those up as a jar. The next step for me is going to be stop using ant. And since that's an extra piece of tooling that has to be on the system in order to make that rake file even work, and preferably just have a simple rake file that can eventually become just a command line tool where you can point it at a piece of code and then it will do everything it needs to package that up based on hopefully the presence of a gem file so it can look for where your gems are bundled at and pull that all together. That's something that I've got some preliminary work done on, but it's nowhere near ready for prime time.
You said that serverless was great for computation-heavy applications, but you mentioned that it was not great for one thing right prior to when you said that. Do you remember what that was you said?
So yeah, if you have something that is computationally constrained, but also is fast enough to happen, because there's a window of computational execution that all the cloud platforms provide. So your computation has to be able to happen within their maximum window. You have some control over that, but you do have limits there because they're not just going to let it sit there and spin. I think on AWS Lambda it may be like 5 minutes. Okay. And so you're not going to be able to do like really heavy data processing with serverless, but that's not the use case for it either. Now the other one, if you have a lot of I/O intensive stuff, because you're going to be waiting for the back and forth, if you have something that's having to make multiple I/O requests, whether to S3 or to a database service, because you can't predict what all the network latency issues are, that may also be a bad use case, but it'll depend on your particular needs. Anybody else? All right, well, if you do have any questions, come find me. I'm easy to spot.